Right, question 16. Circle C1 has centre A and equation given here. Find the coordinates of A and radius of C1. So we rewrite this, so we group the x's together, the y's together. We'll now complete the square. Okay, so we'll have then x plus, of course, 2 all squared. Take away then the square of this, which is 4. Okay, plus then, let's look at this then. We've got the y, take half of that is minus 1 squared, take away the square of that, which is 1, minus then the 20 equals 0. So this becomes x plus 2 all squared plus y minus 1 all squared. And with minus 4 minus 1 minus 20 is minus 25. Take that over, so you get 25 there. Coordinates of A and the radius, basically A will be minus 2, 1. Okay, that will be the centre, A, and then the radius will be 5. Okay, square root of 25 will be 5. Part B then, it says the line L has equation y equals minus x plus 6. Find the coordinates of the points of intersection of L and C1. Okay, so we're going to be interested here as in when they intersect. Okay, so simultaneous equations. So I'll take the first equation as it is at the top, and then I'll sub in then what I've got for y. Okay, so solving simultaneously will give us where they intersect. Okay, so given that y's will be the same when they intersect, so all the x's, but the y's will be the same, so I know y is minus x plus 6. We can sub it in here, so x squared plus minus x plus 6 all squared plus 4x minus 2 then y, which is minus x plus 6. Okay, so all I'm doing is I'm looking at that circle there and I'm substituting in what y is in terms of the line. Okay, and it will be equal, y will equal minus x plus 6. Okay, it will equal minus x plus 6 where it intersects with the line. Okay, because that's what it will equal at that point. It will equal what the line is equal to. So I sub in y in there, I sub in y there, and then of course I've got minus 20 equals 0 at the end. So I've got to do a little bit of work here. Okay, so we're going to have two brackets here, minus x plus 6 minus x plus 6 plus 4x, and then I can times this bracket out because it's a single bracket. Minus 2 times minus x is plus 2x, minus 2 times 6 is minus 12, minus 20 equals 0. Okay, so then I've got all this to simplify, so x squared, now FOIL here, so minus x times minus x. Okay, we'll do that first. First is plus, isn't it? Minus times a minus is plus x squared. And then you've got the outers, which is minus 6x. Inners, which is minus 6x again, and the last, which is plus 36. Plus then 4x, plus 2x, minus, I might group these together, 32 equals 0. So I've got a lot of things to simplify here. Okay, x squared plus x squared is 2x squared. Minus 6x is minus 12x. And then I've got to add these on, so that'll be minus 6x in total. And then plus 36 minus 32 is plus 4 in total. So I've got a quadratic. So I'm going to factorize this now. But now before I factorize, I'm going to divide by 2 because it'll make it much easier for me for when I factorize. It's got a common factor of 2. So if I halve it, essentially, I'm going to halve each term. I have that, and it's much easier to factorize. In fact, when I factorize it, okay, I'm going to have 2 here, I'm going to have 1 here, and they're both going to be minus, and I easily then get my solution because I wanted two numbers that multiply to give 2, add up to give minus 3, both be minus. Minus 1 minus 2 adds up to give minus 3, and then they multiply to give plus 2. So x minus 1 equals 0, or x minus 2 equals 0. So then I can see x is equal to 1 or x is equal to 2. Now they do want the coordinates here, so don't forget we need to work out the coordinates here. So not just the x values, the y values. To work out the y, I think it'd be really silly to put it in here. Okay, you don't want to be putting x is 1 in here because you'll end up with a quadratic and y, and it's a lot of work. Put it in the line. put it in there. So when x is 1, you have minus then 1 plus 6, which equals to 5. So that's one coordinate, 1, 5. And then when x is equal to 2, you'll have y equals minus 2 plus 6. Okay, so I'll just put it in there, and that will equal to 4. So I've got 2, 4. Okay, so that's answered there, part B. Part C then, it says the circle C2 has centre 10, 6 and radius r. Given that C1 and C2 touch externally, find the value of r. Now for this, a little diagram might help you to see what's actually going on. Okay, so if I sort of illustrate that for you, we've got two circles, right, that are going to touch. Now I'm just going to do a sketch, right? This isn't meant to be perfect, okay? I'm not drawing anything to scale or so on. I'm just going to draw two circles that touch. There's the center there, and I'm going to draw another circle that touches. So I'm just going to adjust this to make it so that it looks like it touches. I'll point there. That'll do. Okay, well, it doesn't quite touch, but we'll just pretend it does touch. Okay, so you've got your two centers, right? Now, if we call this, for instance, our C1, right? We know the center of C1 is, we did work it out, didn't we? Minus 2, 1. Okay, that's center A there, isn't it? Okay, and we worked out the radius as well. If I remember, look back, the radius was equal to 5. Okay, radius there was equal to 5. Now they tell us the center of circle C2 is 10, 6. Okay, and they say the radius is r. They don't actually tell us the radius. Okay, what they do though is they tell us that they touch externally. What it means by externally, the circles are outside of each other. You know, this circle could be inside, couldn't it? You could have a circle in here, which means it would be touching internally, but here they're externally, so they're outside of each other. Now we know this radius is r, and they're asking us to work out r. But what's true, of course, if you think about it, if, right, they're touching externally, the distance between the centers of the circle, okay, should be the two radiuses added together. So you should have 5 here and r there added together, which would give you the distance between the two centers. But of course the good thing is I can work out the distance between the two centers because I've got their coordinates, I've got the centers. So I can say the distance between two centers, okay, is equal to, if you remember the formula from coordinate geometry, x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so we'll choose maybe this to be x2, y2, because it's circle 2, it doesn't matter really. So you've got 10 for x there, minus 2 for x here, and then your y2 will be 6 here, minus then 1 for your y1. So that will be then 10 minus minus 2 is 12, so that's 144. Okay, 6 minus 1 is 5, squared is 25, so this will be the square root then of 169, and if you know your square roots, that comes out to be 13. So what we can say then is, of course, that this distance is 13. Okay, so in other words, 5 plus r is 13. You can say that the two radiuses added together will equal 13. Okay, so if that's the case, 5 plus r equals 13, which means r then has got to equal 13. Take away 5, r has got to be 8 for this circle C2.